Now we will cover how to get the triple point temperature using this precision triple point cell. What you see here is water and water vapor. There's no air in here because it was all removed during the manufacturing process. We still need the ice mantle to form though. That'll form around the center well. There are two ways to do this. One way is to take crushed dry ice and pour it down this well. Fill that all the way up. The other way is to use this immersion freezer, also called a quick stick. How this works is you pour liquid nitrogen or crushed dried ice in here, and the temperature will be transferred down this tube. And then you would stick that into the well and let that set. Now this is the preferred method because you can remove the cooling quickly. So if you were making the mantle too large and it was starting to press on the outside walls, it would cause it to crack, which you don't want to break your triple point cell. The goal here isn't to turn all the water to ice, only some of it. We want about 8 millimeters of ice mantle on the wall of the well. And this is kind of hard to tell because of the refraction due to this being a cylinder. Now our mantle needs to be uniform from top to bottom. To do this, we need to keep constant cooling throughout the whole shaft. Now once we're done, we'll know because we'll have that 8 millimeters thickness on our mantle. The next step is to break the ice that's formed around the well. We have to break that loose. And we do that by twisting it very slowly, and also by taking a warm probe, normally warming it up by friction, inserting that down the well, and the heat will radiate off this metal probe onto the walls of the well, which will warm the ice that touches that wall. That ice will then be able to form a boundary layer with water in between the ice and the wall of the well. This is good because if the ice is touching the wall, then you'll only be getting the temperature of the ice, not the actual triple point temperature. You need that boundary layer of water in between. Now once this is properly frozen, it will last about 8 hours, assuming you have a standard bucket with insulating film inside. Some labs can maintain that ice mantle for up to 6 weeks using a maintenance bath that's millikelvin degrees below what this triple point temperature is at, which is 32.018 degrees Fahrenheit, and they would keep their bath at 32.015 degrees Fahrenheit. But now that this is done, and we know how to get the ice to form around the well, we can use our temperature probe that would be hooked up to a data acquisition system, and we would be able to calibrate this probe using this triple point cell.